The universe is an infinite fractal composed essentially of an infinite number of cosmic explosions known as little Big Bangs. If you consult the science textbook published before 2006, you will see that Pluto was included as one of the 9 planets in our solar system. However, this is no longer the case. Almost 17 years ago, the International Astronomical Union, IAU, redefined Pluto's status and excluded it as a planet. Now, the IAU is again debating this issue because NASA has provided clear images of Pluto, now considered a dwarf planet. Join us on a journey to the far reaches of our solar system to explore the first images of Pluto in our history. If you're interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video, share it to reach more people, and turn on the notification bell. We've come a long way since the historic Apollo 11 mission, but the vastness of space poses many unanswered questions. This is where NASA's groundbreaking James Webb Space Telescope project seeks to discover a world of its own. This monumental project builds on NASA's previous missions, and there is great interest in translating special discoveries from prehistory. We are understandably curious to learn more about the Big Bang and how our solar system came to harbor life on one of its planets. The James Webb Telescope, however, has its sights set on the future of our solar system, revolutionizing our understanding. Although it is important to ask whether we need to look back for definitive answers about our universe and perhaps reevaluate them, the Pluto question has been the subject of controversy in the field of space exploration. Thanks to the James Webb Telescope and the discoveries it has provided, we have more and more information to explore our solar system. It seems that the $1.101 billion investment in NASA has led to a revision of science textbooks to include everything we know about Pluto. This time, it is likely to regain planet status. Here's why. Our knowledge about Pluto doesn't end with the controversial IAU decision in 2006. In fact, it is the new and renewed capabilities of the James Webb that have provided the pictorial evidence needed to strengthen our theoretical understanding of this putative planet. Although previous observations categorized which objects are considered planets and which are not, the IAU had little solid data on which to rely. The rules used for this categorization may have been questionable. After the decision in 2006, 2 different scientific positions on the issue emerged. Some believed that the IAU was hasty in declaring Pluto a dwarf planet, while others quickly embraced the new non-planet status. Most space explorers have remained undecided on the matter. However, thanks to the fascinating discoveries of the James Webb, the question of Pluto's status remains. The first sharp images of Pluto, provided by NASA, are rewriting our understanding of cosmic history. The first and primary human encounter with Pluto was conducted by the New Horizons mission, which has been underway for 17 years. In July 2015, the mission achieved its goal by passing close to Pluto and its many moons. This was the first time humans were able to get a close look at the space relic and collect the most comprehensive data set to date about its moons and surface. The New Horizons mission opened up unprecedented possibilities for NASA in its exploration of the Kuiper Belt, a deep region of space. The main achievement of the mission was the detailed study of Pluto, now considered a dwarf planet, and its largest satellite, Charon. It also managed to capture clear images of the 4 other satellites, known as Nix, Hydra, Kerberos, and Styx. Over a period of 15 months, the mission collected data, including the encounter with Pluto and Charon, totaling 6.25 gigabytes. What does this data mean for NASA in relation to the dwarf planet? First, the findings were so groundbreaking that scientists had to develop new data models to better understand Pluto's surface and atmospheric conditions. It was discovered that the dwarf planet was undergoing significant changes in its surface and atmosphere. It was clear that Pluto was far from being a dormant body. It was evolving at a rate that surprised NASA and challenged what was previously believed about this putative planet. The New Horizons mission was groundbreaking, and its encounter with Pluto took place nearly 80 years ago. Since then, the field of space exploration has seen dramatic improvements through technological intervention. With the addition of the James Webb Space Telescope, the possibilities are becoming endless. One might even say that we are getting closer and closer to a complete understanding of our solar system. However, there is an issue with missions like New Horizons and any options to explore planets farther from the Sun. The problem lies in the prioritization of resources, as investing millions to investigate a scientifically important planet may raise questions about the existence of possible life forms elsewhere. Why head to the edges of the solar system? These are challenging questions to be sure. However, the New Horizons mission marked a turning point in the history of space exploration. Not only did it open new avenues for NASA to invest in the exploration of Pluto, but it also piqued our interest in further exploration beyond the known confines. In the case of Pluto, its study is fundamental to building a broader scientific understanding of other small planets. Although it lies in a cold, dark region of the universe, the first images of its surface proved groundbreaking enough to reveal that Pluto is an active object in our solar system. As they say, a picture is worth 1,000 words, and these crystal-clear images from NASA provide us with valuable information. First, Pluto was found to have a heart. Most geological phenomena on this dwarf planet are driven from its core, scientifically known as Sputnik planum. Surprisingly, it turns out that Pluto literally follows its heart. A quick glance at NASA's high-resolution images revealed that this heart is a white, cold, and nearly frozen left ventricle of Sputnik's heart. It resembles a vast nitrogen glacier spanning millions of square kilometers. Another notable geological feature of Pluto's surface is that the axis of its rotation has undergone significant reorientation, a process scientists call precession. This was unknown to NASA prior to the mission. The dwarf planet's basin is in the opposite position than expected. This reorientation has important implications for understanding the dynamics and evolution of Pluto as a planet. In simple terms, the tidal axis between the moon Charon and Pluto is being influenced by Sputnik planum, the heart of the dwarf planet. This influence has reoriented Pluto so that its basin is more closely aligned with the tidal axis, something that was not previously known. We have always known that this ancient planet is uninhabitable for obvious reasons. However, what was not known is that Pluto's icy surface also causes a tilt due to the imbalance in its mass. The core of the heart of the dwarf planet is a 4 kilometers thick layer of ice, which is very likely contributing to that colossal mass. When combined with tides, this process can cause the reorientation of the planet's rotation in search of equilibrium on its own orbit. However, the ice sheet alone is not sufficient to generate a steep reorientation angle or to produce significant heights. As we mentioned before, technologically backed explorations can rewrite our cosmic history, and this is just such a moment. Scientists have also discovered that Pluto is a world with an ocean of its own beneath its thick ice sheets and glacier-covered surface. Pluto's interior contains an extensive ocean that also influences the reorientation of its rotation axis. This discovery is extraordinary for several reasons, but above all because it completely changes our understanding of the planet. The highly probable presence of an ocean in Pluto's crust means that we shall have more information about its origin and how it formed. The discovery of an ocean beneath Pluto's icy surface has ignited new questions and possibilities in planetary science. It challenges our understanding of what constitutes a habitable environment beyond Earth, and prompts us to rethink the dynamics of celestial bodies in the distant reaches of our solar system. This ocean, hypothesized to exist based on gravitational data and now strongly supported by the New Horizons mission's findings, represents a potential reservoir of liquid water beneath a frozen exterior. Understanding Pluto's geological processes is crucial to comprehending its evolution over billions of years. The dwarf planet's surface features, including its prominent heart-shaped region and the unexpected reorientation of its rotation axis, provide tantalizing clues. Sputnik planum, the heart's left ventricle, acts as a unique geologic feature. It's believed to be a large basin that may have formed due to a subsurface ocean freezing and causing the surface to collapse, or perhaps due to an impact that excavated material, leaving a deep depression. The New Horizons spacecraft's encounter with Pluto in 2015 revealed a dynamic world far from the cold, inert body it was once assumed to be. The mission captured detailed images of Pluto's diverse terrain, including mountains made of water ice, vast plains of nitrogen ice, and regions with complex patterns resembling cellular networks. These features suggest active geological processes, possibly driven by internal heat sources or interactions between surface materials and Pluto's thin atmosphere. Pluto's atmosphere, although thin compared to Earth's, plays a crucial role in its surface dynamics. It consists mainly of nitrogen with traces of methane and carbon monoxide. During Pluto's elliptical orbit around the Sun, these volatile gases sublimate from its surface, creating temporary atmospheres that vary with seasonal changes. Understanding these atmospheric processes helps scientists reconstruct Pluto's climatic history and its ongoing evolution. The New Horizons mission's discoveries extended beyond Pluto itself to its system of moons. Charon, Pluto's largest moon, displayed an unexpectedly diverse landscape, including a massive chasm deeper than the Grand Canyon and a dark region nicknamed Mordor for its distinctive coloration. Other moons, such as Hydra and Nix, showed irregular shapes and cratered surfaces, indicating a history of impacts and geological activity. NASA's exploration of Pluto and its moons exemplifies humanity's ongoing quest to explore and understand the outer reaches of our solar system. These missions provide invaluable data, contributing to our broader understanding of planetary formation, evolution, and the potential for life beyond Earth. As we continue to unravel the mysteries of Pluto and other distant celestial bodies, we expand our knowledge of the cosmos and our place within it. With the James Webb Space Telescope now in operation, we stand on the brink of even more profound discoveries. The telescope's unprecedented capabilities will allow scientists to probe deeper into the universe, examining the atmospheres of exoplanets, the birth of stars and galaxies, and the formation of planetary systems. As we journey further into the unknown, the legacy of missions like New Horizons serves as a testament to human curiosity and the unyielding drive to explore the frontiers of space. One of the most surprising discoveries during New Horizons' mission was the detection of potential cryovolcanism on Pluto's surface. Cryovolcanoes, unlike Earth's molten lava-spewing counterparts, erupt with icy materials like water, ammonia, or methane. These cryovolcanoes could provide insights into the internal heat sources that keep Pluto's subsurface ocean from freezing solid, despite its frigid environment. The idea that Pluto may have active cryovolcanism adds another layer of complexity to its geological history. It suggests that the dwarf planet may have experienced periods of intense internal activity, leading to the resurfacing of its terrain and the alteration of its landscape over time. These findings challenge previous assumptions that Pluto was a geologically dead world and open up new avenues of research into the thermal evolution of icy bodies in the outer solar system. In addition to the geological and atmospheric revelations, New Horizons also provided critical data on Pluto's interaction with the solar wind. The solar wind, a stream of charged particles emanating from the Sun, interacts with Pluto's tenuous atmosphere, creating a complex and dynamic environment. Understanding this interaction helps scientists study how Pluto's atmosphere is gradually stripped away by the solar wind, a process that has implications for the planet's long-term evolution and its ability to retain an atmosphere over billions of years. These discoveries have reignited interest in the Kuiper Belt, a vast region beyond Neptune populated with icy bodies and remnants from the solar system's formation. Pluto, as one of the largest and most well-known objects in the Kuiper Belt, serves as a gateway to understanding this distant and mysterious part of our cosmic neighborhood. The study of Kuiper Belt objects, KBOs, like Pluto offers clues about the early solar system's history, the processes that shaped it, and the potential for finding other similar worlds in the distant reaches of space. As the exploration of Pluto continues, scientists are already considering future missions to this enigmatic world. These missions could involve more advanced spacecraft equipped with enhanced instruments capable of drilling into Pluto's surface or deploying landers to study its geology up close. Such missions would provide even more detailed information about Pluto's internal structure, its subsurface ocean, and the potential for life in these extreme conditions. In conclusion, the journey to Pluto and beyond is a testament to humanity's relentless pursuit of knowledge. The New Horizons mission has shattered old paradigms, revealing a dynamic and evolving world that defies expectations. As we continue to explore the outer solar system, we are reminded that our understanding of the cosmos is constantly evolving, and each new discovery brings us closer to unraveling the mysteries of the universe. The International Astronomical Union's decision to reclassify Pluto as a dwarf planet in 2006 was based on criteria that many scientists have since questioned. The discovery of complex geological activity on Pluto, including cryovolcanism, reoriented rotation axes, and a subsurface ocean, challenges the notion that it is simply a small, inert body. These findings suggest that Pluto is a dynamic world, deserving of renewed consideration as a planet. As our understanding of the solar system continues to evolve, the debate over Pluto's classification highlights the need for flexibility in scientific definitions and the importance of revisiting and revising our understanding of the cosmos as new data becomes available. In the grand tapestry of the universe, Pluto's story is far from over. The ongoing exploration of this distant world and its potential reclassification as a planet are emblematic of the ever-evolving nature of science. With each new mission, we gain a deeper appreciation for the complexity and diversity of the celestial bodies that share our solar system. As we look to the future, the lessons learned from Pluto will undoubtedly inform our exploration of other distant worlds, shedding light on the mysteries that lie beyond the horizon.